Hi, welcome back to my class in Advanced Statistics. For today, we will have more examples for constructing a probability distribution for discrete random variable. For our first example, consider the following problem. A retail store received a shipment of 6 small appliances, 2 of which are defective. A customer randomly selects and purchases 2 of the appliances. Find the probability distribution for X, the number of defective appliances among the 2 purchased. The scenario in this problem is that there are 6 small appliances that were recently delivered to a retail store, and there was a customer who purchased 2 of the 6 small appliances, 2 of which are defective. This customer randomly selected 2 of the 6 small appliances and bought them. But 2 of these 6 small appliances were defective. And that we are required in this problem to construct a probability distribution for X, the number of defective items among the 2 items that were purchased by the customer. And the variable X here is an example of a discrete random variable, because the number of defective bought by the customer can be obtained by simply counting. Now, there are 6 of the small appliances, and the customer selected 2 at random among these 6 appliances. First, we find the number of ways that the customer can select at random 2 of the 6 small appliances. And from your course in Statistics 1 or Elementary Statistics, we find the number of ways that the customer can select 2 items at random from 6 small appliances by using combination. So we find the combination of 6 appliances taken 2 at a time. The customer will select 2 appliances at random from 6 small appliances. And the number of ways that the customer can do that is given by a combination of 6 taken 2 at a time. By formula, you can compute this directly from your calculator, because there is a function for combination in your scientific calculator. But by formula, combination of 6 taken 2 at a time is given by the following formula. The combination of n taken r at a time is given by n factorial divided by r factorial times quantity n minus r factorial, where in our problem n is 6, the 6 small appliances, and r is 2, the number of appliances that the customer selected at random from 6 of the small appliances. So we replace n with 6 and we replace r with 2. And this is now equal to 6 factorial divide by 2 factorial times quantity 6 minus 2 factorial. Or the numerator is 6 factorial divide by 2 factorial, multiply by 6 minus 2 factorial. 6 minus 2 is 4 factorial. And we write the expansion of 6 factorial up to 4 factorial. And we stop up to 4 factorial because it will cancel out with 4 factorial in the denominator. Six factorial is equal to 6 multiplied by 5 multiplied by 4 factorial. And this 4 factorial will cancel out with 4 factorial in the denominator. 2 factorial is equal to 2 multiplied by 1, or simply 2. And 6 is divisible by 2, so we divide 6 by 2, and it's equal to 3. And 3 multiplied by 5 is 15. This means that there are 15 ways in which the customer can select 2 appliances at random from 6 small appliances. And these 15 ways correspond to the 15 events in which 15 events of selecting 2 items at random from 6 appliances. Now, of the 6 small appliances, 2 are defective, and we will denote these 2 defective items by D1 and D2. To facilitate our process of finding the probability distribution for this random variable x representing this discrete random variable x representing the number of defective items among the 2 items purchased by the customer, we denote the 2 defective items by D1 and D2. It is given in the problem that of the 6 small appliances delivered to the retail store, 2 items were defective, and we denote these 2 items by D1 and D2. Hence, if there are 6 items delivered and 2 were defective, that means that the other 4 items are non-defective, and we denote these 4 non-defective items by N1, N2, N3, and N4. Now, we will list in a table all the possible events, and there should be 15 events because there are 15 ways by which a customer can select 2 items, 2 appliances at random from the 6 small appliances, of which 2 are defective. We now list the 15 ways by which the customer can select 2 items at random from 6 of the small appliances. And these 6 ways, which we had computed earlier, correspond to the 15 events the 15 ways by which the customer can select 2 appliances at random from 6 small appliances correspond to 15 events. And one of these events is the event where the customer selected both of the 2 defective items from 6. The customer selected the first defective item and the second defective item. For this particular event, the value of the discrete random variable x, which represents the number of defective items among two appliances purchased by the customer, is 2. Another possibility is the event where the customer selected the first defective item and one of the 4 non-defective items, say the first non-defective item. And for this particular event, the value of the discrete random variable x, the number of defective items, or the number of defective appliances in this event is 1. Another possibility is the customer selected the first defective item, D1, and the second non-defective item, N2. For this event, the number of defective items or number of defective appliances is 1. Another possibility, the customer selected the first defective item and one of the 4 non-defective items, specifically the third non-defective item denoted by N3. And for this particular event, the value of x is 1. There is 1 defective item. The first defective item. Another possibility, the customer selected the first defective item, D1, and the 4th non-defective item, N4. For this particular event, the value of the discrete random variable x for the number of defective appliances selected by the customer is 1. And another event possibility is the customer selected the second defective item and the first of the 4 non-defective items. For this event, the number of defective is 1. Another possibility, the customer selected the second defective and the second non-defective appliance. The value of the random variable x for this particular event is 1. Another possibility, the customer selected the second defective item or appliance and the third non-defective appliance. And the number of defective for this particular event is 1. The customer selected the second defective item. Another possibility, the customer selected the second defective item and the last or the 4th non-defective item denoted by N4. For this particular event, the value of the discrete random variable x is 1. Now, we do not write in this listing of events the event N1 and D1 because the event N1, D1 is simply the same as the event D1, N1. The event where the customer selected the first defective item and the first non-defective item is the same as the customer selected the first non-defective item and the first defective item. In combination, if you recall, uh, arrangement order is not important. As long as you have one D1 and one defective and one non-defective, the order in which they are arranged is not important. Hence, the arrangement D1, N1 is the same as the arrangement N1, D1 because in combination, order is not important. Similarly, we will not list the arrangements where the non-defective item or non-defective appliance comes first before the second defective appliance. Like, because for instance, D2, N4 is the same as N4, D2 in combination. Because as I said, in combination, order is not important. So for the remaining events, we select the ways where the customer selected two non-defective items. And one possibility is that the customer selected the first non-defective appliance and the second non-defective appliance. For this event, the number of defective appliance is 0, or the value of the discrete random variable x is 0. Another possibility in which the customer selected two non-defective appliances is the customer selected the first non-defective appliance and the third non-defective appliance. For this event where the customer selected the first non-defective appliance and the third non-defective appliance, the value of the discrete random variable x representing the number of defective appliance in this event is 0. Another event in which two non-defective appliances were selected by the customer is the customer selected the first non-defective and the customer selected the fourth non-defective appliance. And for this event, the value of the random variable x is 0. Another possibility, the customer selected the second non-defective and the third non-defective appliance. For this particular event, the value of the random variable x is 0. Another possibility, the customer selected the second non-defective appliance and the fourth non-defective appliance. For this particular event where the customer selected the third and the fourth non-defective appliances, the value of the random variable x is 0. And the last possibility is that the customer selected, this should be 2 and 2. In this event, the customer selected the second non-defective and the fourth non-defective. And the value of the random variable x for the number of defective items is 0 for this event. And the last event is the event where the customer selected the last two non-defective items, N3 and N4. And for this particular event where the customer selected the last two non-defective items, N3 and N4, the number of defective items among the two appliances purchased is 0. These are the 15 ways by which the customer can select two appliances at random from 6 appliances, of which 2 are defective, and we call these events. And these events are equally probable, which means that each of these 15 events is likely to happen, which means that all these 15 events have the same probability of occurrence, or the same probability of happening. And since we have 15 events that are equally probable or equally likely to happen, the probability of each event is 1 over 15. The probability that the customer selected the two defective appliances from 6 is 1 over 15. The probability that the customer selected the first defective appliance and the first non-defective appliance is 1 over 15. All of these events have the same probability of 1 over 15. We now summarize this table, listing all the 15 possible events into a smaller table. With this now what we call the probability distribution for the discrete random variable x, representing the number of defective appliances among two appliances purchased by the customer. And these two appliances purchased by the customer were randomly selected by the customer from 6 small appliances, 2 of which are defective. And you can see from this table that the values of the discrete random variable x are 3. X can be 0, 1, or 2. The probability of getting 2 defective, the probability that the 2 appliances purchased by the customer were defective is 1 over 15. This value of the discrete random variable x occurs only one time in this table listing of events, and the probability that x is 2 corresponding to this event is 1 over 15. Now the probability that the value of the discrete random variable x is 1 is obtained by adding the probabilities of the events with 1 defective item. The event where the customer selected 1 defective item can happen in 1, 2, 3, 4, 5, 6, 7 in 8 ways. One possibility that the customer selected 1 defective item is this event. The customer selected the first defective and the first non-defective. Another possibility that the customer selected 1 defective appliance is this event, D2 and 2. In this event, the customer selected the second defective appliance and the second non-defective. And there are 8 1, 2, 3, 4, 5, 6, 7, 8 possibilities where the customer selected one defective item. Or there are 8 events where the value of the discrete random variable x is 1. So the probability of x is 1 is equal to the sum of the probabilities of these events. Of these events where there is one defective in each event. Hence we add, this event has one defective, 1 over 15, plus the probability of this event with one defective, 1 over 15. We add this 1 over 15 8 times. And you should get 8 over 15. Now, what is the probability that the customer purchased 2 appliances that were both not defective? And the events, the event that the customer did not purchase a defective item or both items, the 2 appliances purchased by the customer were both non-defective, can happen in 1, 2, 3, 4, 5, 6, in 6 ways. The customer bought 2 appliances that were non-defective, can happen in this way. This one possibility that the customer selected 2 items that were not defective. The customer selected the first non-defective and the second non-defective appliances. Or another possibility, the customer selected 2 appliances that were both not defective, is this event where the customer selected the second non-defective item or appliance and the fourth non-defective appliance. Hence, there are 8 possibilities, or there are 8 events that the customer can select 2 appliances that were both not defective. Or the event that the customer can select 2 non-defective items can happen in 8 ways. And for each of these 8 ways, or for each of these 8 events, the probability of each event is 1 over 15. And the probability that x equals 0 is the sum of the probabilities of the events where the value of the discrete random variable x is 0. Thus, to get the probability that x equals 0, you simply add all these probabilities p of x where x equals 0. You have 1 over 15 plus 1 over 15. You will add 1 over 15 to itself how many times? 1, 2, 3, 4, 5, 6 times. So the sum of this 1 over 15 is 6 over 15. Now we check. There are 2 properties of probability distribution. The probabilities corresponding to the values of the discrete random variable x. Should be greater than 0, positive, or less than equal to 1. Since 6 over 15, 8 over 15, and 1 over 15 are positive but less than 1, then this first property of probability distribution is satisfied. The second property of a probability distribution, which is also a way of checking whether you have the correct probability distribution for the given discrete random variable x, is that the sum of the probabilities corresponding to the values of the discrete random variable x is 1. In symbols, the summation of the probabilities of x of I, where the values of the discrete random variable x range from 0 to 2, should be 1. So we expand this probability, x is 0. The second property of probability distribution, the probability that the random variable x is 0 plus the probability that the discrete random variable x is 1 plus the probability that the discrete random variable x has a value of 2 should be 1. The probability that x is 0 is 6 over 15. Plus the probability that the discrete random variable x is 1 is 8 over 15. Plus the probability that the value of the discrete random variable x is 2 is 1 over 15. And the common denominator is 15. We simply add the numerators. 6 plus 8 is 14 plus 1 is 15. And 15 over 15 is 1. Therefore, our probability distribution for the discrete random variable x representing the number of defective appliances among 2 appliances purchased at random by the customer among 6 small appliances, 2 of which are defective, is correct. For your practice, please try the following exercise. An investor randomly selects 2 utility stocks from a group of 3. Of these 3 stocks, 2 possess higher growth rate potential than the third. Let x be the number of stocks with the higher growth potential that are contained in the selection. A, this is what you will do. Find the probability distribution for x, where x is the number of stocks with higher growth rate potential or higher growth potential that are contained in the selection. And the investor will randomly select 2 stocks from 3 utility stocks. And letter B, graph P of x. That means you draw the probability histogram. And that completes our lesson for today. In the next lesson, we will have another example. And the last example for constructing a probability distribution for discrete random variable. If you have questions about the lesson today, you ask your question in the comments below. And don't forget to subscribe to my YouTube channel, Art Kalisan, the channel of learning and leisure. Please also ask your friends and your classmates to subscribe to my YouTube channel, Art Kalisan, so they may learn as well. Thank you for joining me in my class today.